Okay, so I think most of you have joined. So good evening. I am Subhadip. I am the CP lead of GDSC TMSL. And I think most of you are from first year and some are from second year. So let's start today's session. Let me share my screen first. Okay, is it visible? You can write in the chat, yes or no. Okay, great. So today's topic is competitive programming. This is going to be a little bit introduction of what is CP, and then we'll see why it is important to learn CP, and then a little bit of roadmap, how you can be 5-star on Codesave and candidate master on Codeforces. Then we'll see some important CP topics and then some famous platforms to learn CP. So first of all, let's see what is CP. So the full form of CP is competitive programming. You can call CP most like a mind game. Like you can compare it playing like a chess. In chess, what happened is that you have some position, and from that you have to find the best possible moves in order to win the game. This is exactly what CP is. You are given an unknown problem and you have to find a solution of it. And instead of like moving the pieces in the chess, here you just have to code your solution. You don't need to write any English approach or any editorial like that. You have to code it in any accepted language. It can be C++, Java, Python, or anything. Now, if I tell you about doing some optimal approach, let me tell you what an optimal approach is. If I tell you about a problem, suppose you have given a number n and you have to find a sum of the first n natural number. Like for example, suppose your n is given as 5 and you are supposed to find the sum of 1 plus 2 plus 3 plus 4 plus 5. Now, what can be your approach of solving it? You can write in the chat or you can think in your mind. What would you do if you are given this problem? You are given a number n and you have to find the sum of n natural number. Okay, I'm giving you 30 seconds to think. For loop, n into n plus 1 by 2, again a loop. Okay, so as we can see, there is mainly two approaches. The first one is running a for loop from 1 till n and sum all of those 1 to up till n. And the second thing is using n into n plus 1 by 2 using the very basic formula which you all know. Now, what do you think? Which is going to be the better approach? Either the first one, the for loop one, or the second one using the formula. What do you think? Which one is going to be better? Which one is going to be more optimized, to be said? Okay, first one, second one, first one. Okay, some of you are saying for loop. Now, some of you are saying the formula one, right? Now, let's see. Suppose you are given a number as 1000. Now, if you are trying to find the sum using the for loop, then what are you going to do? You are going to do 1 plus 2 plus up till 1000. And if you are using the second approach, using the formula, then you are just doing n into n plus 1 by 2. So in the second approach, you are just multiplying two number and dividing it by 2. But in the first approach, you are doing the addition of 100 numbers. So what do you think? Which is going to be more time consuming? Which will take more time? The loop one, of course. So we can easily see that that the loop one is going to be more time consuming than the first one. And if the number is 10 to the power 9, let's say 1000 is very small number. Suppose your number is 10 to the power 9, then this will take a lot of time, the for loop one. But again, using the second one, where we are just doing the multiplication of two number and dividing it by 2, this will take almost a constant time. So this is what optimization is. And in CP, you have to do a lot of optimization. You will see a lot of optimization technique and solve the problem using those optimized approach. So why CP is important? What do you think? Why CP is important? Now you can consider CP as a hobby. Like you play games as a hobby, you watch movie as a hobby. Now you can also do CP as a hobby, but you are not gaining much considering it as a hobby. But if you look alternatively, this eventually improves your problem solving ability. Now, how does this problem solving ability, improving this problem solving ability helps you? In interview, what happens is that there can be two types of question you can encounter. Either a very standard problem, which you have already solved using in any platforms like LeetCode, GFG, or you can encounter a whole new, different problem, completely new problem. Now, if you are doing CP for a long period of time, then answering those and come up with a solution of those completely new problem is not very difficult for you because you are doing that for a long period of time. In CP, nothing is very standard. You always have to come up with a whole new approach. And also in recent, before doing an interview, you are supposed to give an online round where there will be some problems and you are supposed to solve it. Then you are eligible to give interview. And for that also CP is really important because you have a, let's say 2 hour or 2.5 hour of time and you are supposed to solve 3 problems. Then if you are doing CP, then this is not very difficult task for you. And just a second. Yeah. Now let's see what is the roadmap to become a candidate master and on Codeforces and 5-star on CodeSafe. So if I tell you how to start become candidate master on Codeforces and the 5-star on CodeSafe, so the very first thing is learning a language. Now there are three main languages to start with CP. One is C++, one is Java, and the other is Python. Now, how many of you are using any of these three? You can write in the chat. Which one of these you are using? Like if you are using C, then I would suggest you to switch it. C is not that much helpful in case of CP, doing CP. C++, Java, or Python. I know all the three, great. So like there can be many cases. Whether the first case is that you don't know any language, then I'll suggest you to start with C++. And if you are doing Java or Python for a longer period of time, let's say you have already done CP using Java, Python for 3 or 4 months, then I'll not suggest you to switch into C++. But if you are completely new into CP and you don't know any language, then I would suggest you to start with C++. Now, why? Why you should start with C++? The very first advantage of using C++ is the runtime that C++ provided is very low. Now, what is runtime? Runtime is the overall time that your solution takes to complete or to execute. Now, if I talk about an example, suppose you are given a problem, and if C++ takes 1 second of time, then on an average case, a Java language takes 1.5 seconds and a Python language takes 4 seconds to complete. So as you can see, C++ is already 1.5x faster than Java and 4x faster than Python. So that is again one example of using C++, one advantage of using C++. And another thing is that whole the CP community, almost 85% of CP community use C++. And if you are using, and almost all the editorials, like if you are giving a contest, after sometimes there will be an editorial board, whether it can be any YouTube video or it can be any blog. And all those solutions are already written in C++. Like most of the solutions are already written in C++. As I have said already, almost 85% of the competitive programmer uses C++ as their main language. So that is again another advantage of using C++ as a topics. And after that, have you all heard about the term DSA, data structure and algorithm? Like how many of you know DSA already? Now, what does DSA mean? DSA means, let's say you know array, you know linked list. How many of you already know? Okay, great. So if you are doing CP, then there are like very basic thing to start. Like there is a very misconception on among students that, okay, first I will start all the things. I will learn DP, I will learn graph, then I will start CP. Now this is a very common misconception. The very minimal requirement to start CP is know how to take input output, how to run a if else statement, how to run a for loop, and how to use array and string. Now that is a very minimal requirement to start CP. If you are not If you are not familiar with array and linked list, then I'll not suggest you to start CP. But if you are familiar with array and linked list and the previous topics, then you can easily start CP. You can easily give a code safe diff3 round. This will not be a problem. And after that, if I talk about DSA, then I will not suggest you to learn linked list or binary search tree topics like that. The linked list, binary search tree topics are like not really common on CP. Yes, you can use array, linked list, vectors, something like that, but linked list and binary search are never used in CP. And if you are looking CP from interview point of view, then you can start CP now and you can learn those remaining topics in the last 1 month or two. Like if you are doing CP, then again, learning those things are not really going to be tough for you. Now, what I can do is that I can share my journey, how I become candidate master on code forces and a 5-star on CodeSafe. If I talk about my journey, then I have learned C++ on December 2020, and on January 2021, I registered on code forces and gets familiar with the platform. Before that, I have also solved some problem on HackerArt and HackerRank. And after practicing 1 month on CodeSafe, I gave my first contest on CodeSafe, which is on February 2021. And after that, I become 5-star on October, I guess. Let me just show you my graph here. So let me just log in into CodeSafe. So as you can see here, I have given my first contest on, okay, this is the new rating graph. I think some of you know that CodeSafe changes its rating system. So this is the old graph looks like. So I have given my first contest on February 2021, and I have become 5-star on October 2021.
স্ক্রিনটা দেখাচ্ছে না।
Screen দেখাচ্ছে না, just a second. Okay, is the screen visible to other? Let's see.
ওয়ার্ড ডকুমেন্টটা দেখাচ্ছে।
Yes, it is visible. I think you have a problem, Abhishek.
Yes, yes, it's visible. Continue.
Okay, great. So as you can see here, and I have a strip rating graph. Like there is no saturation. Now, what is saturation? The saturation is something by which most of the competitive programmer quits doing CP. The saturation is something like for a longer period of time you stuck on some rating. Now in CodeSafe, I do not face any saturation graph because it just increases and become 5-star. This is something I have. This is of 2022. I am saying like this. As you can see, the graph is very upwards. But if I talk about my code forces journey, then there is a long period of saturation. Let me just show you that again also. So as you can see in the graph, like in October 2021, I become 5-star on CodeSafe, and I also become expert on code forces on October 2021 onwards. And after that, there is a very long period of saturation. As you can see in the whole range, my graph is almost on the expert range. And the next level is candidate master, which haven't reached after the October 2028. And as you can see here, I reached candidate master on June 19. So there is a very long saturation period, and most of the computer programmer tends to quit in that saturation period. That my rating is not increasing, I'm gonna quit it and I'm gonna learn something else. Now this is what you should always avoid. There is always been a saturation period, but you can absorb that, or you can get out of the saturation from solving more number of problems. If I see you my submission graph, as you can see here, there is too many submissions I have provided on that particular time to get out of my saturation range. Now this is how, and most of the time you have to practice and you have to absolve contest. Suppose you are giving a contest, and this is very unlikely that you have solved all the given problems. Like suppose there are 6 problems and you have solved, let's say 3 of those. Then you must absolve the 4th one, and if possible the 5th one. This is how you can improve. And let's say you just know those topics, like till the string part I have already said, and you do not know anything else. Now, in a contest, you have faced some problem which is based on dynamic programming. Now, what you can do is that you can say, okay, now I need to learn dynamic programming, and you can watch some YouTube video or the editorial of the contest itself to learn DP. Now, this is how you can improve yourself. Like if I talk about myself, I never learned DSA, then CP. I have learned DSA along with doing CP. So this is, I think, the most optimal approach of doing it. And now we'll see some CP topics. Now, if you have any doubt, you can ask in the chat. If you have any doubt till now, or if you have any question regarding how to, okay, let me just open the chat. I'll also say how you can start CP in the very last, on which platform you should start CP in the very last of the session. Okay, if you haven't any doubt, then let's go to learn some CP topics. Let me just clear this. This is the first topic we'll learn today. So the very first topic is primality test. Now, what is primality test? As you can see here, primality test is basically you are given a number n and you just have to say whether that number is prime or not. Now, how you can determine if a number is prime or not? Now, we can say a number is prime if there is no divisor in this range, 2, n minus 1. Like for example, if I talk about 11, 11 is a prime number because there is no divisor in the range 2, 10, right? You cannot divide 11 by any number between 2 and 10. You can only divide 11 by 1 and 11 itself. So this is the condition of checking whether a number is prime or not. As you can see here, if I talk about 11, we should return true that yes, 11 is a prime number. If I talk about 16, then 16 is not a prime number because we can divide 16 by 2, 4 and many. That is why it is not a prime. And by definition, 1 is not a prime number. If you have asked a question that is 1 is a prime number or not, you should always say no, 1 is not a prime. Now, what would be the approach of solving it? What do you think? You can write in the chat again. What would be your approach of solving this problem? For loop? Yeah, we can use loop. Can you also elaborate your approach? I'm giving you 30 seconds. Like what would be the range of those for loops? Like you are saying for loops. Yes, it is for loop. But what would be the range? What would be the lower bound and upper bound of those range? Check number of element from 2 to n minus 1. Yes, I think that is a great approach and the most basic one. And by using if else, right? Great. So the very first approach that comes into mind is we can run a for loop from 2 till n minus 1 and we can manually check that whether that number is divisible by n or not. Whether that number divides n or not. And if any of this number divides n, then we can say n is not a prime. And if after the ends no number divides n, then we can say n is a prime. Now, let me also show you the code of the basic approach. 1 second. Let me just open this in my editor. Okay. So this is going to be the loop, right? Now there is only one base case. If n is 1, then we should always return. Now here 0 means false and 1 means true. This function should return 0 if my n is not a prime number, and this function should return 1 if n is a prime number. Now, as you can see here, by definition, if my n is 1, then this should not be a prime. So I simply return 0. And after that, we run a loop from 2 till n minus 1. As you can see here, I less than n means I goes up till n minus 1. And after that, the condition becomes false and it breaks out of the loop. And if any number I divides n, then we can also say return 0 because that number is not prime. And if that number is, if any of these I cannot divide n, then after that we can return 1 and we can simply say that yes, my n is a prime number. And if I also give an input, let's say give an input of 23. So 23 is a prime, we all know, as you can see here. And this function, as I have said, this native function should return 1 if this is a prime number. So we can also give it like that. If native of n equal to 1, because n is a prime, then native of n should return 1. As you can see here, 23 is a prime, and if I give any non-prime number, let's say I give 16. So 16 is not a prime number. So have you understand the approach or not? Now, what do you think? What is going to be the complexity of this problem? Or how many times this loop runs for a number n? So you can say this loop runs from 2 till n minus 1. So you can also say that this loop runs almost n times, right? Because it is just not running 1 and n, but it is also running for all the numbers between those twos. So you can say the time complexity of this problem is n. The time complexity is basically how much time this should run for a number n. So the time complexity of this problem is n because we are running a for loop from 2 till n minus 1. Now again, if suppose you are given an input like 10 to the power 9, let me also give this. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now if I run this, okay, 10 to the power 9 is not actually a prime number. It just get divides by 2. That is why it is giving this much less time. But if I give any non-prime number, let's say 10 to the power 9 plus 7 is not a prime. 1, 2, 3, 4, 5, 6, 7, 8, and just a 7. This is a prime number. I have already know that. So as you can see here, my code just goes on compiling this. And this takes a lot of time to run this. As you can see, let me just clear. This does not get executed in 1 second. This will take a hell lot of time. This just goes running, running, and running. And this takes almost a lot of seconds to run this code. So this is not an efficient approach. Now, in order to optimize it, we just have to look into some observation. Now, what is going to be that observation? Now, the very first observation is that all the divisor of n occurs in a pairs of a comma b such that a into b is equal to n. Let's see with an example. Suppose the value of n is 24. Now, what is going to be the divisor of 24? 1, 2, 3, 4, 6, 8, 12, 24. Right. Now, we can form a pair such that this condition satisfies. A into b is equal to n. As you can see here, the very first number and the very last number is itself equal to n. 1 into 24 is equal to 24. The second number and the second last number is also, the multiply of second number and last second number is also equal to 24. Very similarly, the third and the third last, and the fourth and the fourth last, and we don't have any remaining number. Now all of those forms a pair a comma b such that a into b is equal to n. Let's also see for 18. Now in case of 18, we know the divisor is 1, 2, 3, 6, 9, 18. As you can see here, 1 into 18 is 18, 2 into 9 is also 18, 3 into 6 is also 18, right? And also one more interesting thing to observe is that in this pair of a comma b, one number is below square root of n and the other number is above square root of n. Like for example, if you check any pair, what is going to be the square root of 24? It is going to be 4 point something, right? Because square root of 25 is 5. So square root of 24 is going to be 4 point something. And one number is below square root of n and other number is above square root of n. This is true for every possible pairs. Like if you randomly pick any pair 3, 8, 3 is less than 4 point something and 8 is greater than 4 point something. So this pairs always holds true, that one number is below square root of n and another number is above square root of n. Now there is only one exception. What if n is a square number? Suppose 16 is a square number, we all know that. Now what is going to be the divisor of 16? This is 1, 2, 4, 8 and 16. And how does this pair forms? The pair is a into b equal to n. As you can see here, 1 into 16 is 16, 2 into 8 is 16. But here 4 itself multiplies and gives me a 16. Right? So this is an exception where both a and b is equal to square root of n if n is a perfectly square number. So what we can say is that if a number is divisible by this range, 2 comma square root of n, now what is going to be the square root of n of 16? 4, right? So we just have to run a loop from 1 till 4. And if that number divides, then we can simply say that it is not a prime number, because the range of 1 comma square root of n, sorry, 2 comma square root of n is also between 2 comma n minus 1. And if there is a number divides that n, then we can also say n is not a prime. And what happens if there is no divisor in this range? Suppose we do not find any divisor in this range, 2 comma square root of n. Then is it possible to find any divisor a comma b where both a and b is above square root of n? Like, try to think. Suppose you have given a number n, and suppose square root of n is something s. Just a second. Square root of n is something equal to x. Now, is it possible that x plus 1 into x plus 1 will be equal to n? Is it anyhow possible, or any combination where both the number is above n? Let me just see the chat. No. So this is not possible, right? Where both the number a comma b is above square root of n and a into b gives me a value of n. So instead of checking from 2 comma n minus 1, like what we are doing in this approach, instead of checking from 2 comma n minus 1, what we can do is that we can just check from 2 comma square root of n. And if there is no divisor in this range, this also means that we cannot find any divisor in the upper range, like square root of n plus 1 comma n minus 1. And we can say that this number is not a prime number, is a prime number if we do not find any divisor. And there is a little bit of optimization of doing it, as you can see here. Here, instead of running this loop from 2 till n, like here, as you can see, we are starting this loop from 2, and we are ending this, we are running this till n minus 1. Here, instead of running this till n minus 1, we just have to run this till root n. Now, how does this loop ensure that this will run till root n? Let's say I have a number of 16, and let me just run this function. Instead of letting we are native, we are supposed to run is prime function. So 16 is not a prime. 16 is not prime, and also let me just show you for 23. 23 is prime. So how many times this loop runs? We can also print the value of I. Suppose my value of I is 23. How many times my value of n is 23? What is going to be the value of I? We can also see it. As you can see, my value of I runs up till 4, not more than 4. Why? Because first my value of I is 2, then 2 into 2 is 4, which is less than equal to 23. Then again 3 into 3 is less than equal to 23. 4 into 4 is less than equal to 23. And after that, whenever my value of I becomes 5, then 5 into 5, which is 25, which is not less than equal to 23. So the loops breaks and simply gives me the answer that this number is prime in case of 23. And here, instead, if we use this approach, and here if we try to see the value of I, let me just run this approach once again. As you can see here, I am running this loop from 2 till n minus 1. Here n minus 1 is 22, so this loop learnings from 2 till 22. So this approach becomes much more optimized. Here, instead of running this loop from 2 till n minus 1, we are just running this loop from 2 till square root of n. So we can see the time complexity of this approach becomes big of square root of n. Now, is there any doubt? You can ask in the chat. Otherwise, we can go into the next topic. Also, let me just show you a problem which is on Kickstart. Why we should use this optimized approach and why not the basic one. So here the problem is very simple. Given a number n, and we just have to check the number is prime or not, and the function is also is prime. And if we copy this first approach, my first one, the basic one, which is running from 2 till n minus 1, let me just clear those and paste it here. This one is the basic approach I am pasting, and let me also do a little bit formatting, compile and run. So my output is equal to my expected output. Let's just submit this. So as you can see here, I am getting a something like expected time limit is your program took more time than expected. So I am basically getting a time limit exceeded error because my loop runs till big of n. My time complexity is big of n, and here the value of n is as you can see here 10 to the power 9. And generally a loop for computing 10 to the power 9 times, for running a loop till 10 to the power 9 times, it almost takes 10 seconds. And here my time complexity is at most 1 or 2 seconds. In any standard platform, you will be getting at most 1 or 2 seconds of time, not more than that. And here this approach should take 10 seconds of time. That is why I am getting a time limit exceeded error. Now here, if we paste this optimized approach, let's just paste it. Also, what is going to be the square root of 10 to the power 9? What do you think? It is somewhere around 10 to the power 5. And 10 to the power 5 easily runs into 1 second. Let me just do compile and run. Again, my output is equal to my expected output. And if I submit this, so as you can see here, my total time taken is already 0.1 millisecond. It's 0.1 ms. So this is a way where you can optimize your approach from big of n till big of square root of n in case of primality test. Let me just. Okay, is there any doubt understanding this topic? Otherwise, you can jump into the next one, which is going to be the GCD. We can also do it using if else. Yeah, we are also using it if else also here. Like, let me just show you the code again. The if else is always necessary. Otherwise, you cannot do it. I am also giving the if else here, as you can see. If the if statement is always needed. Now else part does not get executed. Like let me just give you an example. Let me just open my sublime. Suppose the value of n is 9. Now if you do else returns 1, then what is the problem? Can you identify? What is going to be the problem here if I do else return 1? If n mod I is equal to 0, then it is not a prime. Great. Otherwise, can I say that it is a prime? What is going to be the problem here? Let me also run this approach. As you can see here, it says 9 is a prime. How? Can you identify why it is saying 9 is a prime if I am just using else? So what is going to be the very first value of I? The very first value of I is 2, right? Now you are simply saying if 9 is divided by 2. No. Then you are saying that 9 is a prime. Now is it true? Here we are just dividing I as 2. Here we are just comparing the value of I 2. We are not going into the second loop. We are not comparing again into it 3. We are supposed to check all the values between 2 till this range, not just 2. This is why the else is not required. If you are giving else, you get a wrong answer. What times matters in CPU runtime of the code? Like you are supposed to solve it between 1 second and let's say the value of n is up till 10 to the power 6, then you can use at most big of n or big of n log n. And if it is 10 to the power 3, then you can use a big O of n square approach. And if it is more than 10 to the power 3, let's say it is 10 to the power 4, then if you are using a big O of n square, then sometime it pass, sometime it gets TL'd. Or if the value of n is 10 to the power 5 and you are again using big O of n square, you will definitely get a TLE here, because it checks only odd and even, not prime number. Yeah, right. Again, exactly. For odd number, this gives me a yes, and for even number, this gives me a 0 or no. Now the next thing is GCD of two number. Now you all know what GCD is. You are given two number and you are supposed to find the GCD of it. Like for example, the GCD of 9 and 15 is 3. The GCD of 10 and 30 is 10 itself. The GCD of 2 and 5 is 1. Now what is going to be your approach? Can you write in the chat? You can write in the chat what is going to be your approach if you are asked to solve the to find the GCD of two number. I'm giving you 30 seconds to think. Smallest number which can divide both. Yeah, exactly. GCD is not the smallest integer, the largest integer. Suppose if I give you an example, in case of 9 and 15, 1 is also dividing 9, 1 is also dividing 15. Then why it is not 1? This is 3. So GCD is the largest integer by which we can divide both the numbers. Like in case of 10, we can also divide both the number 10 and 30 by 5. But the GCD of 10 and 30 is 10, right? Because this is the largest number by which we can divide both of them. Yeah, GCD is also known as HCF. We have to check from 1. Okay. What is the first thing that comes into your mind? What is going to be your approach if you are given a problem to find the GCD of two number? Okay, now let's see the approach. The very first, the native approach, which is going to be pretty much intuitive. Now suppose your number is a comma b, your input is a comma b, and you are supposed to find the GCD of a comma b. Now can I say that GCD is always less than equal to minimum of a comma b? Can I say that? Just tell me a yes or no in the chat. That my GCD is always less than equal to a comma b. No. Okay, suppose Subham, let's say you are given you are supposed to find the GCD of, let's say, x comma y. Now what is going to be the condition of GCD? If the GCD is equal to, let's say, g, then x mod g should be 0 and also y mod g should be 0, right? Now if g is greater than your x or g is greater than your y, then how this can be 0? Like what you are saying is that you can divide 4 mod 5 and you can get a sum of 0. Can you get 4 mod something which is greater than 4 as 0? 4 mod x is 0 and the value of x is greater than 4. Is it ever possible? We divide b by a till b mod a is equal to 0. No. So again, we can say this condition always holds true, that my GCD is always less than equal to minimum of a comma b. Okay, so what is going to be my native approach? What we can do is that we can run a for loop from 1 till minimum of a comma b, because we always know that minimum of a comma b is going to be the largest number by which we can check that whether that number is eligible for being a GCD or not. And after that, we find the largest number which divides a comma b. And again, the time complexity is minimum of a comma b because my loop runs the minimum value of a comma b. Let's say my minimum value, let's say one number is 10 and another number is 10 to the power 9. Then my loop only runs till 10, not 10 to the power 9. And if both the number is 10 to the power 5, then my loop runs till 10 to the power 5, not 10 or something. So my time complexity is going to be minimum of a comma b. Also, let's see the code. Let me show you the code of it. GCD. Okay, so here we are doing in taking two parameters as a function parameter, and we are initializing a variable as x, and we are running a loop from 1 till minimum of a comma b, because I know there is going to be, if there is a GCD of those two numbers, then this always lies in this range only, not outside this range. And if I divides both the number a and b, then I is going to be a GCD of my number. Then I is a GCD, I is a number which can be my GCD. Then I am updating x as my GCD. And eventually the last number which gets updated by x is going to be my GCD. Also, let's check with the approach, and I'm taking two input. Let's take the example input only. 9 and 15. 9 and 15. So as you can see, my GCD is 3. Also, if I print the value of x here, let's check which number divides both. So I am printing those i's and 15. This is the number which divides 15.
Just run this.
Divides both the number, because one always divides all the numbers, and 3 is going to divide both the number. There is no other number which divides both the number. And again, my GCD is going to be 3, because I am updating my x as I, and the last value of I is 3, which satisfies this condition. Also, let's check with other example. Let's give a value of 24 and 36. So these are all the eligible candidate to be my GCD. One can divide both the number, one can be my GCD. Two can divide both the number, as well as 3, 4, 6, and 12 can divide both the numbers. But as we have already said in the exam, in the definition, that GCD is always going to be the largest number. So 12 is going to be my largest number. So is the approach clear with everyone? How we are calculating this GCD? We are just doing a brute force from 1 till minimum of a comma b, and if that current I is dividing both the number, then I can be a possible GCD. Then I am updating x with I. Yes, great. Now, how to optimize this? Now, this complexity is again minimum of a comma b can be up till 10 to the power 9. If you are say in a problem, you are given an input where a and b can be up till 10 to the power 9, then this is going to be TL8. Now, the approach of calculating two number of GCD of two number is known as Euclid algorithm. Only the name is dangerous, not the approach. I think this approach is known to all of you, right? Have you ever used GCD? Like when we are in school, how do we calculate the GCD of two number? Are we using for loops, like is one dividing both the numbers, two dividing both the numbers, like that? Or we are following this approach only, using this divisible operation? Yes. I think this approach is known to everyone, all of us. We have already done this. So we can formalize this like this. GCD of a comma b is GCD of, let me just write one more line. GCD of a comma b is like that. We are dividing, the divisor is b and my dividend is a, and we can structure it like this: GCD of b comma a, where my divisor is b and my dividend is a. Now let's see this approach of calculating GCD of 15, 40. So we are getting a remainder of 10 by dividing 15 by 40. And again, we are using this 10 as a divisor and this 15 as a dividend. Again, I am getting a remainder of 5. And again, this 10 comes here and becomes a dividend. And then we get 0. And whenever we get a 0, we can say this current number becomes my GCD, right? So we can say GCD of 15, 40 is my 5. Now what happens here? If I try to structure it like this, we can say GCD of, can we say GCD of 40, 15? Let me just also, GCD of 40, 15 is equal to GCD of 15, 10. Can I say that? Just take this two step. Just notice this two step. GCD of 15, 40 To calculate the GCD of 15 and 40, we are also using 50, 10 and 15. So can I say that GCD of 40, 15 is equal to GCD of 15, 10? Yes, good. And we can also say that GCD of 15, 10 is also equal to GCD of 10, 5, right? And again, this is equal to GCD of 5, 0. And whenever I get a 0 as my reminder, I can say this current number is my GCD. This is the approach we are following here. Have you all understand that? Good. So we can try to generalize this as a formula. GCD of a comma b is equal to a if my b is equal to 0. As you can see here, this is my b, this is my a, this 5 is my a in this step, this 5 is my a by following this structure, and my b is 0. Whenever we get a 0, we can say my GCD is a. Now, what if my b is not a 0? Then we can say that GCD of a comma b is equal to GCD of b comma a mod b. Let's also try to use this here. What is going to be GCD of 40, 15? GCD of a comma b is GCD of b comma a mod b. What is going the value of b here? 15, which becomes which comes in the place of a next time, and the value of GCD of 40 mod 15 comes in the place of b. As you can see here, 15 comes in the place of a, and the value of 40 mod 15 comes in the value of position of b. And very similarly, the value of b becomes the next the value of a in the next step, and GCD of 15 mod 10 becomes the value of b in the next step, and again the value of b becomes the value of a in the next step, and GCD of 10 mod 5 is 0, which becomes b. Now my b is equal to 0, so then we can say GCD of a comma b is equal to a. So this is a very general way of solving it. Okay, I have also written it here. GCD of 40, 15 is equal to GCD of 15, 10, which is also equal to GCD of 10, 5 and GCD of 5, 0. Have you all understand this approach? Now this is the main observation here. If you have understand it, just tell me a yes in the chat. Okay, great. Now what if a is less than b? Now what does it I mean to say is that let me just clear this one. This is not needed. What if a less than b is like this? I am dividing 40 by 15. Now what is going to be the problem here? We always know we always used to, like, if we want to calculate two number, we always take the small number here and the large number here. In the place of dividend, we take the large number, and in the place of divisor, we take the small number. So what if I have given a number like this? Now let's see what happens here. If we try to use this formula, GCD of 40, 15, okay. GCD of 40, 15 is, if we use this formula, let's say GCD of 15, 40 is equal to GCD of, just use this formula, GCD of b, a mod b. What is the value of b here? The value of b here is 15. The value of b here is 40, right? In this example, the value of b is 40, so we can simply write 40. And what is going to be the value of a? 15 mod 40, a mod b. Here the value of a is 15 and the value of b is 40, so 15 mod 40, which eventually gives me a 15, right? So as you can see here, if my number is a comma b, it eventually gets converted into, if my number is a comma b and a is less than b, it eventually gets converted into b comma a. And we know this number becomes always greater than this one. So this problem gets easily resolved. We don't need to exceptionally handle it. Like we don't need to pass a always lesser and a always bigger and b always lesser. If a is less than b, then it automatically gets converted to this one. Also, let's see the code of it. Okay, before that, have you all know recursion? Like, do you familiar with this term recursion or not? Okay, like if you don't know recursion, then this is you can learn it, then you can code it. Also, there is a non-recursive approach. I have also written that. Just understand the logic, and once you have learned those topics, you can easily code it. The recursive code looks something like this. I am passing two number a comma b, and if my b is equal to 0, like in this example, uh, if my b is equal to 0, then we can simply say that the value of GCD is going to be a. And if my value of b is not equal to 0, then we simply have to do a recursive approach of b comma a mod b, where b comes in the place of a, and in the place of b, the value is going to be a mod b. Like this one, what we are doing here. Also, there is going to be a non-recursive code here. Just try to understand that. Here we are taking a variable reminder and say, let's check. We are passing two number a comma b, and while b is greater than 0, that also means while b is not equal to 0, b cannot be negative, right? So if b is not greater than 0, then b is always going to be equal to 0. Then we are storing this a mod b in a reminder, and we are swapping this. We are swapping the value of b in the value of a, and uh, we are swapping the value of remainder in the place of b. So as you can see here, now my value of a becomes b, and now my value of b becomes a mod b. So we are doing the same thing here while b is not equal to 0. Now both this approach gonna work. This is a recursive code, and this is a non-recursive code. Also, let me just run those approach. GCD recursive one first. So as you can see here, GCD of 24,36 is going to be 12, and GCD of, let's say, also run the recursive code and non-recursive code one, GCD of this. So this is also giving me a 12. So both of these code can work. You can also write this one, the recursive one, and the non-recursive one. Now let me know if there is a doubt or not till now. Like how all of you got this code, understand this code or not. Again, if you are not familiar with recursion, you can also try to loop this iterative approach. Here we are not using any recursive code, and we are maintaining the condition again. While b is greater than 0, we are swapping the value of a into b, and we are updating the value of b into a mod b, and until b is 0, until b is greater than 0, we are running this loop. And after all, when b becomes 0, this loop breaks, and we are simply outputting a. That which one is better, VS Code or Sublime Text, and why? Okay, I think I have preferred Sublime Text because the run because the load is very low. This is a very lightweight software, and it gets like it takes 1 second to load. Like if I load this software, this hardly takes 1 second to load, and I have got all my previous code and all. That is why I prefer Sublime Text for doing CP only, but doing development, VS Code is all obviously better because you can also download some cool extension and doing this. Also, there is a problem. Let's see this. Okay, also there is one more thing. Like, have you all know this formula? The multiplication of two number a comma b is equal to the GCD of a comma b into the LCM of a comma b. Have you all know this formula? A comma, if my G is GCD of a comma b, and if my L is LCM of a comma b, then A into B is always equal to G into L. Have you all know that? Now suppose you are supposed to find the LCM. Now how do you find it? You already know how you can find the GCD of two number using this approach. Now if you use this formula, A into B is equal to G into L, and you can easily find the LCM of two number by using this formula, the sum of two number by the GCD of this number. This is how you can get the LCM of two number. I think this is a very well-known formula, and you all have already known that. And if you do not know this, no problem. And let's see the problem here. So I have given two integer and I am supposed to find the GCD and LCM of a comma b. And here what I am doing is that just check this one. There is also test cases. What is going to be the test case? That this tree means I have to check for three pair of a comma b. As you can see here, I have the value of t as 3. So I have been given the value of a and b 3 times. So just check this code. I am taking the input of a comma b. I am finding the value of GCD of a comma b, and I am supposed to output the GCD, then a space, and then the LCM. Again, as I have already said, the value of LCM is going to be the sum of those number by the GCD of this number. Now, why this 1 LL? Do you know what this 1 LL is? Like, what is the function of this 1 LL? Also, let me just submit it without using this 1 LL, and let's see if there is any problem or not. As you can see, my output is matching with the expected output is matching with my current output, and I'm submitting it. So I am getting a wrong answer. Can you say why I'm getting a wrong answer? Like, this is going to be this is a tough question actually. If you do not know what is 1 LL, or if you do not have any experience with CP. Do you understand why this 1 LL is necessary here? Like, again, if I submit this is going to be give me an AC most probably. I'm just adding this 1 LL. 1 LL means I am just multiplying it by 1. Again, you can say that multiplying a number by 1 is not going to change the value of it, right? But again, also let's just wait for the result. So I am getting a correct answer. So as you can see, I'm just multiplying the value by 1. So what is going to be the problem here? Can you identify? If you observe here, the value of a comma b is going to be how much? 1, 2, 3, 4, 5, 6. So what is going to be this value, a into b? Let's say that my value of a is 10 to the power 6 and my value of b is also 10 to the power 6. Now what do you think? What is going to be the value of a into b? 10 to the power 12, right? 10 to the power 6 into 10 to the power 6. Now what is the maximum number that integer supports? Do you know that? What is the maximum number that my int support? And do you heard about the data type long, int long? Have you been familiar with that? So the maximum value that my int support is that, let me also show you by a function. There is a function, there is a, this is going to be the maximum value that my int support, int max. And this is almost equal to 2 into 10 to the power 9. Now, whenever I am multiplying two number and that exceeds my n, let's check what is going to be the problem. Suppose my value of a is 10 to the power 6, 1 is 6 is also equal to 10 to the power 6. Now my value of b is also equal to 10 to the power 6. And I am storing it as a result. Also, let me just remove this line. Result is equal to a into b. Now this should give me a 10 to the power 12, right? Now if I run this code, as you can see, I am getting some garbage value with a negative sign. Like, this is very strange. I am multiplying two positive number and I am outputting the result of it. Like, if I multiply 4 and 5, then this is giving me a correct value, 20. But if I am multiplying 10 to the power 6 into 10 to the power 6, this is giving me a garbage value. What happens is that the value of a into b gets exceeded by the int limit of int. What an int can store is at max of 2 into 10 to the power 9. But here the original value is 10 to the power 12. So int cannot store that. So what we have to do, we have to typecast it to long. And for doing that typecasting, we have to do this 1 LL. Now if I run this approach again, as you can see, I'm getting 10 to the power 12. So that is why the 1 LL is important, because the value of a into b can exceed 2 into 10 to the power 9 and apparently gives me a negative number, as we have already said here, some negative garbage number, and some negative garbage number divided by GCD also gives me a wrong answer. That is why I am getting wrong answer the previous time, and here I am typecasting it to long, and a into b 10 to the power 12 supports long, because the long can support at max 10 to the power 18, and here the value of a into b is at max 10 to the power 12. So this is why I have to give this 1 LL here. 2 to the power 31 minus 1. Yes, exactly. This is the right, which is almost equal to 2 into 10 to the power 9 and some more numbers. Also, is there any doubt till now? Otherwise, you can jump into the very last technique that we have to see. So let me just open that. No doubt. Good. Have you all already familiar with the concept of array? Like, do you know what an array is? Okay, great. Also, if you do not know, let me just give you a brief of array. Let's say you have to store two numbers. Let me just write a template. Suppose you have to store two numbers. Then what you can do is that, or you can say to variable int a comma b and c in a b and c out a and b. And if I run this code, I should get 2436. And also let's just separate them by a space. So I'm getting 24 and 36. So for storing two number is like, we can store two number by taking two variable. Now let's say you have to store 100 number. Then what would you do? This is very difficult task, right? By using those A, B, C, D, which can goes up till 10 to the power, which can goes up till 26. Then after that, you can also do something like A1, A2. But again, handling those is very difficult. Again, after, let's say you have handled 100, then some of you say, okay, say that, okay, I want to store 1000 number now. Then again, you have to write 1000 different variables, which is going to be pretty much a problematic situation. So that is why the concept of array comes. Let me just give you a little bit of introduction of array, and then we can jump into the problem. So this is the syntax of array. Here we are defining that error of 5 means I have declared a 5-sized array. Now, how we are going to access those variables? Like here, in the previous case, what we are doing is that we have two variables a and b. Now here, what is going to be the variable? In the previous case, we have two variables a and b, but here the variable are something like that. Error of 0 is going to be my first variable. Error of 1 is going to be my second variable, and like that. Error of 5 minus 1. Let's say, let me also define the size n equal to 5, and I am creating an array of size n. This is the syntax of an array. And error of n minus 1 is going to be the last number. Like for example, if my value is 2, then error of 0 is going to be my first variable. Error of 1 is going to be my second variable. And this is how I have created a variable. I have got two variables named error of 0 and error of 1 instead of error of a and b. Now here, suppose one has said that I want to create a variable of 1000. Then again, no problem, right? We are again creating a value of array of size 1000, where the variable can be like error of 0, error of 1 up till error of 999. So this is a way to store large number of variables by creating an array, not just creating two random variables a and b or something like that. Not familiar with C in and C out. Okay, so have you familiar with, like, which language are you using, Chris? C in and C out is basically taking the input and output. Like, this is very simple. Suppose, let me just clear those. Suppose I have a variable a. So C in A means I want to take a input of a. and C out means I want to output it. This is all C and C out. Like this is very simple. I think much more simpler than using C. So if I am taking the value of C in of A, so the value of A becomes 5 and I am doing C out of A, so my 5 gets output here. And if I am not taking any variable C in of A and I am using some random variable, let's say 10, then this should output a 10. So this is what C in and C out is. This is used to take input and output in C++ language. For basic only C. Like this is much simpler than C. In C, you have to write scanf, then %d, %l. You have to think of all of those. But in here, you just have to do C in and C out. In case of everything, like if this is a character, then you do not need to write some %c or something like that. This also works for C in of A in case of character. Let me also show you that. Suppose char A is equal to 10. And if you want, suppose you want to give the character as G. So as you can see, I am getting G. So this is what C in and C out is. So have you all got the concept of an array? Like what an array is, what is the use of array, but why the array is needed here. Now the problem of prefix sum is like this. You can read this problem. Suppose you are given a array ARR and you have Q queries. Queries means you are supposed to give some output for certain problems. Now, what does each query consist? Each query consists of two integer I and j. And you have to find the sum of this whole range, I and j. Now, what does that mean? Suppose you are given a query of I and j, then you are supposed to find this whole sum, error of I, comma error of I plus 1, up till error of j minus 1, up till error of j. And this is always given that I is always less than equal to j. I is less than equal to j is always given. So this is what my problem is. Have you understand the problem? Also, let's check with an example. Suppose my array is something like this, 8, 3, 5, 4, 1. So my value error of 0 is 8, and very similarly error of 4 is 1, because my size is 5 and error of 4 is going to be my last index. And if I have given a query of 1, 3. Now in array, we are following zero based indexing. So for 1 is going to be the second element. So you are supposed to find this 1, 3 range. So this is my 1, this is my 2, this is my 3. So you are supposed to find the sum of this whole number. So this is 12 here. And in case of 0, 1, so again I have said 0 is the first number and 1 is the second number. So 8 plus 3 is 11. And again 0, 4 is basically the whole range. 0 is my first number, and for n equal to 5, 4 is going to be my last number. So the value of whole range is going to be 21. So this is what I have to find. Have you all understand the problem? And if you have understand, can you say the approach? Like what comes to your mind intuitively? What are you going to use to solve this problem? Now again, that the query can be multiple. Like for a single array, you can give multiple queries. Like the array size can be 10 to the power 5, and the query can also be 10 to the power 5. Now, what is going to be the basic approach? The basic approach is going to be, we can simply run a for loop from I till j, and we can calculate the answer of it. Right? Like the thing what we are doing here, we are running my for loop till error of 1. This is my error of 1, and we are updating this 3 plus 5 plus 4, 12. For
Just wait for a minute. He got disconnected for some technical reasons, I guess. Just wait for a minute. There is some net issue, and he'll be joining in 2 to 3 minutes. Just wait for some time.
Hello, hello. Am I audible?
Yes, you are.
Sorry for the interruption. My laptop just got hanged. Okay, is my screen visible? Also, let me just open up.
Yes.
Prefix. So have you all understand the first approach, running a loop from I till j? Yeah, I think that approach is pretty much simple, right? Just run a loop from I till j. Now how to optimize this? Now there is something named as prefix sum array. Now what prefix of I is doing? Prefix sum is array of also, prefix sum array is also something like similar to an array, and the size is also same like the original array. The prefix sum array of an array is also equal. The size is also equal for both of those. The prefix sum array is the sum of all the element from 0 to live. The prefix of I stored the sum of all element from 0 to live. For example, if my array is something like this, 83541, then my first element prefix of 0 is going to be stored the sum of error of 0. Prefix of 1 is going to be stored the sum of error of 0 plus error of 1, which is going to be 8 plus 3, 11. Again, very similarly, prefix of 2 going to store the sum of 0, 1 plus 2, which is 8 plus 3 plus 5, which is 16. Very similarly, for prefix of 3 is going to store for 20, and prefix of 4 is going to store 21. So have you all understand what a prefix sum array is? Like what is a prefix sum array? How do we calculate the prefix sum array? Here, from this array, how do we get into this array? Have you all understand this approach? Okay, great. Now suppose I have been given a problem that I have to find the sum of, I have been given a query that I have to find the sum of 0, let's say x. If I have been given a query that I have to find the sum of, let me just write here, sum of 0, x, then can I use this query, this prefix array directly? Can I say that prefix of x is going to be the sum of 0, x? Can I say that? because we already know that prefix of I is going to store the sum of all element from 0 till I. Now, if I have given a query that I have to find the sum of 0 comma x, where I have to start from 0 and I have to go till x index, then can I use prefix of x here? What do you think? Like in this example, if I have to find the sum of 0 comma 3, 0 1 2 3, then can I use this here 20? Can I directly say 20 that the sum of this 0 comma 3 range is going to be 20? You can also manually verify that 8 plus 3 plus 5 plus 4 is going to be 20. And this is what the prefix sum array is. It is going to store the sum of element from 0 to I. So can I say that sum of 0 comma L is going to be 0 prefix of L, and sum of 0 comma R is going to be prefix of R? What do you think? Yes, great. I think this is very intuitive because prefix of L is itself says that I am going to store the sum of 0 till I. And if I want just sum of 0 till L, then I can simply use prefix of L. Now, I have to
Fix of sum of L comma R.
can I use this formula? I have also give a email
And the sum of this
range. Now
I know
0 comma R, right? I know the sum of this range. By using prefix of R, I can directly get the sum of this range. And by using prefix of L minus 1, I can directly get this range. And if I subtract this from this one, then I can also get the sum of this range. And here you can see that sum of L comma R is sum of 0 comma R, which is the sum of 0 comma R is this one, prefix of R, and sum of 0 till L minus 1, which is prefix of L minus 1. And if I want the sum of this range, then I can simply subtract this from this. Have you understand this concept? How we are getting the sum of L comma R by using prefix of R minus prefix of L minus 1. Like you can also manually verify it. Let's say, okay, before manually verifying, what if my L is 0? There is only one exception where we cannot use this one. Suppose my value of L is 0 and I am using the same formula again. Prefix, let's say the value of R is 2, 0 comma 2. So prefix of R is 2 and prefix of L minus 1 is 0, 0 comma 1, which is going to be minus 1. And we are accessing the minus 1 index of an array, which doesn't make any sense because we can only access from 0. We cannot access minus 1, right? So in that case, we can simply say sum of 0 comma R is going to be prefix of R, which is by definition, we can say it. And if I talk about the example here, my array is this and my prefix array is this, which we have already calculated. Now, suppose I want to query 1 comma 4. Now 1 comma 4 is this. 1 is my second element. 2, 3, 4. Right. Sorry, this one. This is the main array. Now, the query of 1 comma 4, my answer is going to be 3 plus 5 plus 4 plus 1, which is going to be 13. And if I want to use it by using prefix sum, if I want to calculate it, then we just have to use this formula. Prefix of L is 4. Sorry, prefix of R is 4. So prefix of R minus prefix of L minus 1, which is going to be 1 minus 1, 0. As you can see here, prefix of 4 is my 21, 0, 1, 2, 3, 4. So my value of prefix of 4 is 21. And the prefix of 0 is 8, which is also equal to 30. Now, what do you think? What is going to be the complexity of this approach? Like how many operations do we need for calculating this one and also the previous one? But for creating prefix sum array, we have to run a loop. So what will we gain from it? Okay, we'll also see how we can create a prefix sum array. You don't have to run the loop for each test case separately. Exactly. So we can also say this is a big O of 1 approach. This is a constant approach. Can I say that this is a constant approach? Because here we are just doing a subtraction of two numbers. But here we are running a loop. So this can be the distance of R comma L. Right. So this approach is much better. Now, how do we create the prefix array? That is also a question. Let's just let me just show you the code. Now, let's say my array is like this. I think I am using the same array 83541. Was it 83541? Yes, it is. And my value of n is 5. I'm just hard coding it. I'm not taking any input here. Now, prefix of 0 is error of 0. Can I say that? My prefix of is 0 is going to be error of 0 always. Can I say that? Because prefix of 0 means what? The sum of 0 till 0, which is going to be the value itself at the 0th index. Now, this is a very interesting thing here. How do we calculate the prefix sum array using big of n? Like running a single loop, not a n square loop. What is my prefix of I? Let me just give you some visual representation here. Suppose you have already calculated till this index and you want to include this one. You have already calculated this range prefix array and you want to include this range, this one element. And how do you do that? One thing you can do is that you can simply run a loop from 0 till this one, from here till here. Again, calculate prefix of I plus 1 here. Another thing you can do is that you can use the previously calculated value. You already calculated this range, right? If you are calculating I, then you have already calculated I minus 1, right? And if you have added error of I here, then this is going to be simply give me the answer. If I am adding error of I with my prefix of I minus 1, then I can simply get this array, my prefix of I. Have you understand that? Like of it, where this is big of n, why this is not big of n square. Also, let me just run this code and also just comment this out. As you can see here, I am getting the expected prefix array, which is 8, 11, 16, 20, 21. So here what we are doing is that my prefix of 0 is going to be 8. And for calculating prefix of 1, we are just multiplying prefix of 0 plus error of 1. So 8 plus 3 becomes 11. Also, suppose my prefix array becomes 8. And then prefix of 0 is 8 plus 3 becomes prefix of 1 becomes 11. Now for calculating prefix of 2, what we can do is that we can simply run a loop from here till here, 8 plus 3 plus 5, which is going to be 16. But we can also use the previously stored value, 11. And we can simply add 5 with this 11. Because I have already calculated this value. So why do I again calculate this one again? I have already this value here, 11. And very similarly, for calculating this value, we can simply store 16 plus 4, which is 20. And after that, 20 plus 1, 21. This is how we can create the prefix array in a single loop, not in a n square loop, like nested loop. And again, for doing the query, I am passing it in a function. You can see here. So again, this is the base case. If my L is equal to 0, then simply return prefix of R, otherwise return prefix of R minus prefix of L minus 1. Also, let's just validate. Let's take all the queries one by one. Let's take the first query, 1, 3. 1, 3. So we are getting 12 here, and also, okay, let's just leave the prefix array as it is. So what it is going in the function, the value of L is 1 and my value of R is 3. So prefix of R is what? Prefix of R is prefix of 3, 0, 1, 2, 3. Prefix of R is 20 and my prefix of L minus 1. My value of L is 1. So it's simply subtract 20 minus 8 because L minus 1 is 8. prefix of L minus 1 is 8. So I am getting 12. And also if I have used 0 here, 0 comma let's say 1. 0 comma 1 is how much? 8 plus 3, 11, right? As you can see, I am getting 11. But if I have not used this condition, then this should give me some garbage value, as you can see here, because I am accessing prefix of -1, which never exists. So this condition is really needed. Otherwise, you can simply use this general formula. Okay, is there any doubt? What will be the time complexity of the first method? In which, like, computing the prefix sum or doing the query? Like in case of query, you can say the time complexity is going to be q into n, because in the Oates case, all my query lies can be L equal to 0 and R equal to n minus 1. And again, for every time, we have to run this loop n times. So in the first case, my time complexity can be big of query q into n. And in the second case, my time complexity can be big of n. For calculating the prefix sum, we have to run a for loop up till n. And for calculating all the queries, just q, because this one is constant time. So just a q. As you can see here, this is much more optimized than this. This is q into n, and this is n plus q. Okay, if you have any doubt, you can ask in the chat. Also, I have also attached those problem links. You can also check those. And let me just open once. And I'll share the zip file in the WhatsApp group maybe. This is again the same thing. You are given an array of size n, and you have to find the sum of elements from index I till index j, which is again the same thing. And here the query can be very large. Like if the query is, if the value of n is 10 to the power 5, and if the value of q is also 10 to the power 5, then this will give definitely give a TLE. And if you follow this prefix sum approach, then this is not gonna TLE it. Also, I am assuming there is no doubt. Now let me tell you some famous platform to start with CP. Like there can be case where you do not know any language till now. So what you can do again, you can start with C++ and you learn the input output, the for loop, the if else, and array and string. Then you can simply go into code save. And okay, before that you can start with hacker rank. If you are from first year, second year, you can start with hacker rank. And if you are from third year, then I'm not suggesting you to start CP. You can simply do lead code. In after doing hacker rank for, let's say you have done hacker rank for 7 and 8 days, after that no need to stick to that platform. You can simply come into CodeSave and give some contest. Like there is a famous contest named as long challenge, which holds for 3 or 7 days. Okay, as you can see, that status is currently live. It holds for 3 days. You can try to give this contest. This is very much useful for if you are a beginner. You can learn so many things, and as the time is whole 3 days, then you can simply learn a lot of things. This will definitely improve your problem solving ability. And after that, you can jump into giving short contest. Again, after one more famous platform is Code Forces. I would suggest once you become 3-star on CodeSave, you can jump into Code Forces and also try to start giving contest here, because Code Forces is not for directly beginners. Like if you have just learned loops and arrays and you jump into Code Forces, then the problem is going to be very tough for you. But if you have already become a 3-star on CodeSave, then you can solve problem on code forces. Also, there are many famous contests like one is Google Kickstart. Google Kickstart is a very tagmark contest of Google. It holds 8 times in a year, and you can definitely try to start participating here. Once you become, let's say you are 3 star on Coursera, then you can easily solve one problem on Google Kickstart. So try to give this contest. As you can see here, there is going to be 8 contests from round A till round H, and holds throughout the year. The very first contest holds on March 19. So you can also try to register on that. And if I talk about another, then there is going to be ICPC, which is a like team game. And if you qualify or become top from your college, then you can go into some regionals. Like there are 4 regionals: Kanpur, Amrita, Puri, Kharagpur, and Pune. You can go and go into the on-site and participate into that also. And also there is going to be a Google Solution Challenge from GDSC. This is going to be an open source competition. Let me just show you also. So this is going to be an open source competition introduced by Google, and we will also have a session onto that, like what is going to be the, how you can register, how you can form a team, and like that in the upcoming days very soon. Also, if you have any doubt, you can ask. What if I start with lead code with sorted easy question first? Yeah, you can do that. But if you are from first and second year, then I'll suggest you to give a CPU, to give CP a try of at least 1 or 2 months. Then if you are not liking it, then it is really fine. You can do lead code. And if I talk about sorted easy question first, then yes, you can do that, but do not do all the easy question first. Like try to give a mixture of those. Like you should not be too comfortable with the question you are solving. You should always face a challenge while you are solving. Is lead code hard for beginner? No, definitely not. This is why it is hard. Uh, you can start with lead code easy. I think lead code easy is very straightforward, but lead code hard is definitely not. Also, if you do not have any doubt, I think this is the end of the class. This is the end of the session. You can leave the meeting. So do we learn a language in very deep, like every elements of it? No, this is definitely not needed at all. Like this will never end if you try to learn everything of a language. As I have already said, you just have to learn those array string, and then you can start anything. And in case of development perspective of view, then also again the same thing. You do not have to learn the whole things. Like there are so many things in JavaScript. There are so many frameworks, so many libraries. You cannot learn the whole things. You just have to learn those which are needed in your current situation.
So, hi guys, I hope you guys enjoyed the session. And if you want even more sessions or want to interact directly with him, you can contact him in college or in LinkedIn also, or can directly message him. And so, I want a feedback like, how was it? And Shubhadeep did a great job. So, great work, Shubhadeep.
Thank you. Okay, also, let me just share my number in the chat. You can message me if you have any doubt regarding CP or not. Okay, I have shared my number in the chat.
You can WhatsApp him, contact him in college also. He's from IT third year. And if you want further more sessions, reach out to any of us so that we can arrange one for you. Thank you everyone for joining. Subhadip, I think we can end the session now.
Yeah.
Rishita?
Hello, am I audible?
Yeah, we can end the session now then.